So welcome. In this video, we're going to talk about the basics of reverse engineering. Now, this is a sample challenge I've prepared for this video. Now, whenever you're getting a particular challenge, I'm working on the Linux environment. You can work on Windows, and I guess it will be pretty much the same workflow because most of the tools we are going to use will be available for both systems directly, or you could get it with some means. Now, first of all, this is a challenge executable. The first thing is whenever we get a challenge or any executable, we are not providing malware out here, we know that, so we'll be executing that and checking out the output, right? So if I just run that challenge, yeah, it's asking for a password. Now if I just give a random input and it gives me incorrect password. Now what am I supposed to do is, like, the first lead I have got for this particular challenge is I have to find out this password, or what is it asking for, in order to get something out of it, right? So the first thing we should ideally do for these kinds of challenges is check the strings inside this executable, right? So to do that in Linux, we can just do the on Linux we can just do strings and challenge, strings challenge, and we'll be like piping the output to a text file. You could do it on console too, but it's more convenient that way. Now what this will do is it will extract all these strings present in the challenge executable and show it to us, right? What is the point of that? We'll be able to see some interesting things, and we'll be getting more leads to what we might have to do in order to reverse engineer this in a better way, right? So let's just run that. Now strings command might not be available on Windows, but you can still go ahead and use any online utility, or you could get strings command through string utility through some systems like the git bash, or I guess it was available through the MinGW installation. And there are ways you can get strings on Windows, but you could also use some online utility and they will do it for you, right? Now I can open this up in any text editor. Now I can see there is a lot of strings out here, and a lot of it doesn't make any sense. Now this is a tedious job. We have to actually go through all of this to find something interesting. Now, well, that is one thing we could do, but if we are being clever, we could do something more clever, like by, let's say, whenever we run this challenge, we are getting a prompt that says enter password, right? Now this prompt itself is a string that is stored inside the executable, so that too must be in there in this list, right? So why not try to find that? We could do that pretty easily by copying this. Let's say copy and find out here, paste it, and we found that. Now ideally, if you like, this is something you should know about executables, is there is a high chance that all the executables that this particular all the strings that this particular executable is dealing with, that we should be interested in, we might be interested in, will be around this particular string itself. That is something we might find in the usual case. Why? Because all the strings of the particular program we are writing should be grouped up together, right? Now that might not be the case in some cases, in some executables, but well, it's the usual thing. So, and we found the things, right? There is the flag executable. Now this is, I guess, will be printed whenever we are entering the correct password. Now there is the error code executable. There might be some reason it is there. There is the connection established one. There is an IP address. Now this looks interesting. Now by seeing these strings, we should get an idea about what the application might be doing behind the scenes. Now by just running the application, we might not understand what exactly it's doing, but by looking at this strings, we might get an idea of what it is doing. Now whenever we are seeing an IP address, well, everybody should have guessed that it might be trying, we cannot say it for certain, but it might be trying to connect to this IP address, right? And this looks like a port number. So let's just try and see what it is trying to connect to, and that might give us the answer. So, well, this is trying to connect to this IP address. Now how can I track that? How can I track this network, and then track the network to check whether what IP address this is trying to connect to, or what kind of traffic this is trying to send or get from that IP address? Well, we are going to use a tool called Wireshark. Now you can install it on Windows, on Linux, and it's pretty easy to use. Let's see. I'm going to start that up. Alright, so you'll get this kind of an interface. Now Wireshark is there. We are going to start capturing your packets. What this does is it taps your network. It taps your own network. You can select the network you're trying to tap. I got a lot of these out here. Now the one I'm interested in is this ETH0. Right, I'm going to start the tapping and start capturing, and you can see all the packets that are passing through my computer will be passing through this particular, will be shown out here, right? Now if I just go ahead and rerun the executable, and we can see we have got some traffic and it's looking interesting. Now if we see carefully, we can see that this particular IP address is coming up out here. Now it's trying to connect to that IP address. Now what are the packets? Let's just try and observe those packets. Let's just open it in full screen. Now you can see there is a SYN packet, there is an ACK packet. Now these are basically packets for like handshakes, the TCP IP handshakes. Now these are some internal packets. Now you should be knowing these kind of things. These are basics. You can Google it about basic networking, and you can see what are SYN packets, what are ACK packets. Now these are basic TCP IP handshakes. Now we can see that after that there is an HTTP request from our IP address. This is the source, this is our IP address, and this is the destination. This is what the IP address we are trying to connect to, and that's the IP address that's present inside our the executables binary, right? After that, we can see it's getting a response. Again, there is an ACK packet, and we're getting a response from that particular server. Now, these are not something we are interested in. These are like something that might deviate us. So one thing we could do out here now, in some cases also that we are in my computer, I'm getting only these few packets, but in a lot of cases, you'll get a huge list of these packets. Now your computer might be connecting to some other network. For example, you have Chrome active. Now Chrome might be trying to open up some websites. Now if you have Windows might be trying to connect to Microsoft servers. Now there is a lot going on in the background, so ideally you should filter this with some kind of a filter. So firstly, you've got this IP address, so let me just copy this up, and I can do something like ip.addr, and out here I can just paste this IP address. Now you can see only communications between this communications to and from this particular IP address is being shown out here. Now this will help us in trying to filter out stuff that we might be interested in from the regular noise that will like waste our time. Now let's just try and see the contents of these HTTP requests. First, let's see the GET request. So it's this application provides a lot of information about the particular request, the packets being sent. You can see the IP addresses, you can see the networks, how it reached the network. Now a lot of things are being shown out here. We are not interested in all of that. Let's only see the contents of the HTTP protocol. Now there is a GET request that is to this URL, that is to this endpoint, that is dummy at the get pwd. Now again, if we see the internals, you'll see that this is a simple web request. Now we also can see that there is a user agent. Now this user agent, if you are interested, if you are knowledgeable about programming networking in C++, so you might have heard of this library called cpp httpliv. Now this is a library for networking in C++. So this also gives us a lead that this application, this challenge executable, might be written in C++, right? Again, that is a hint. So we will try to extract information about this executable from everywhere possible. Now next we see the response that we got from that particular request, HTTP request. And well, this is the response. Now we've got a status code 200. That means everything is okay, and we've got a content length 20. Now let me just close it up. All right, we've got content length 20, and there's content. We're getting a lot of stuff, other stuff too. We can ignore. Now the interesting part will be the content of this request response, right? Let's just close this up. We'll see line-based text data, this text HTML. That is the response we got from the server. If we just open it up, we'll see that there is our password. Now this might not be the password, but well, this looks like a password, so just why not copy it? Like right click there, copy and value, and then we can just go in the terminal and try and paste it. Oops, not the IP address. Copy this, copy value, again paste. Okay, and we have got our flag. All right, this is the flag that we are supposed to find. Now we can just copy this and paste it in our the portal, and we'll get the points for that. Now this is basically how we can reverse engineer stuff. Now this is done for this particular executable, but let's just go ahead and try to explore more of reverse engineering using this same example. Now we could also try and find out like how this executable works internally, like literally its code by disassembling it, right? Now the tool used for that is called Ghidra. Ghidra is a tool developed by the NSA, and it's a very great tool for trying to decompile a program and seeing its contents. Let's just open it up, Ghidra, and let's just start it up. Okay, Ghidra is also cross-platform. You can run it on Windows and Linux. I can just open I have to create a project. Let's say, yeah, create a project. Let's say something temp. All right, so there is an existing folder with that name. So create a project, and all right, challenge, and create it. Now I have to import this particular executable out here. All right, now you can see it's already giving us a lot of information about that executable it's loaded. So you can see it's an ELF executable. Now on Linux, the executables are of ELF format, executable and linking format. This is the language it's used, the destination folder and stuff. We can just click OK. You could click options and try to configure it more, but for our purpose, we'll just see the basic things. Now here's a lot of information about that particular executable, the things it's importing and stuff. Now I will just ignore this for now and click OK. Now I'll just double click it and open it up in Ghidra. All right, let's just wait for that. Now click yes. Now what is analyzing? Analyzing, it's like we'll take the code in assembly for that particular executable and try to create similar looking code in more high level language like C and stuff, to like, which will help us understand what things are going on in there. Now the defaults are pretty great for these kind of stuff. We can just click and analyze right here and wait for it to be done. You can see it's doing its job out here. All right, so wait for it. Now let's okay. All right, so I guess we should move on now. All right, so first things we can see is the UI, and out here the thing we might be interested in is the symbol tree, and more importantly the functions. Now ideally there is if you're lucky, not ideally, but if you're lucky, you might find something called main out here. That is the main function out here. We can see the main function out here. Now this is basically the main function of your program, and this solves a lot of problem for us. Like we'll be finding, like we'll be getting the exact entry point for a program, but if the executable may not have the main function. What I mean is this main function may be hidden. Like it could strip off, the executable could be stripped off of its function names, or the optimization algorithm might just remove this main function, the name of the main function, to something else. You might not find it. So there is other way to find something relatable for our executable too. First, we got our main function. We know that this is our main function. Let's just forget about that. Let's say there is also hash function or something like that. No, let's just forget about that and just close it up. Now we don't have. Let's assume that we don't have our main function in this list of functions. How we can find or get to something closer? Again, that should be easy enough. What should we do? Do is, when we remember that whenever this program is starting, it's printing this message, that is enter password. Now we can just copy this and try to search it inside this code, inside this assembled code. So what we're trying to do is we'll try to find usages of that particular string inside out here. So if I just do Control-Shift-E and paste this up here, and we'll just take all of these and click search all and wait for it to be done. Oops, search all, yeah. We can see there is only one use of this, and let's see global, and this is the place where it's being declared. Now this is not very interesting, so let's just try something else. Let's just remove this password enter thing and just the password. Let's search for only password. Now ideally you won't be able to finding anything like password or strings like this usually in a normal executable, so this might be something that this particular executable has, or that's from that string, right? Now out here you can see that it's all referring to this particular namespace, that is a function, that is the main function. Again, like this we could find the main function. That's another way to find that. Now that time it won't be named main but something else, but this is another way to find something, get a lead of what to do. Now out here you can see a lot of stuff is being declared. Now this looks like C. Yeah, it's C kind of, because you see undefined code. These are some things that maybe the disassembler could not identify, but we can just ignore that for now and just look around on the code. Now this looks like a C++ code. How can you say that you can see these things are being used? This is clearly C++, right? Now we are trying to allocate stuff. Now this basically, I guess this is allocating a string, and now std string, that is allocating it, and you can see the IP address we are trying to reach. Again, there is some other string out here that we are trying. There is some other string. Now, as far as you can guess, this is a string being allocated with the IP address being set. For example, you can see allocator, and yeah, so a string variable is being allocated, and this value is being set to that, I guess. Now we can move on and try to find out what is actually happening. Again, a string is being allocated with the value this 8787 out here. Again, out here, this is the local 8B, I guess, is the port number. Now next thing is, if I just move on, I'll be finding that there is the deallocation, that is the destructor is being called out here. That is, maybe the string is popped off the stack at this point of time. Then there is a loop, right? We can also rename variables out here. We can rename this to, let's say, I, that loop variable I. So, and out here there is a hexadecimal number. We might not be comfortable with that. We can just right click and choose to like change it to decimal. And out here, now these are also a lot of hexadecimal numbers, but I'm not changing it because, you know, see the size of the numbers. There is a very less chance that they might be something interesting to us. You see, this number cannot be something interesting in most of the situations, right? Now, if I just move on, I can see a string function is being called, that is operator plus. What is happening out here? This line, what exactly is happening out here in this line? Let's just try to understand that. If I just open up a text editor, let's do it without this out here. Okay, let's go down. All right. Now, what exactly might be happening here, I guess, is, you know, we're calling operator plus of local 8f. Where is local 8f? Local 8f, local 8f, what is local 8f? Okay, let's find that. Okay, where is that? Okay, let's just try and rename that to something like interesting string, because this is a string. We are calling operator plus of string with firstly this and secondly something. We'll try to understand what that means later, just in a moment. Now this is, let's say, interesting string, and let's try and find the references of these out here. Now let's try find that. Okay, where is that? I can control F, next, previous. Yep, you can see this is basically a string initialized to null. This is basically this statement. If I just copy it, and this statement will be equivalent to something like std string, let's say interesting string, equals to this, right? Something like this, because in C++, these operators are going to be changed to either constructors or something like this kind of function for classes. Now string has an operator, the plus operator overloaded, so you can see something like this will be something changed or compiled to something like this, or not compiled exactly. This is something that Ghidra is trying to figure out for us, and like it's not being able to get to this directly, and it's only being able to go to this part, so we have to try to understand what exactly it means. Now let's say that next thing is, if we just go follow this thing, we might say that this particular stuff is the port variable. Let's say port. Okay, port. Again, we are trying to create a port. Let's say I'm trying to write the code out here in a more decent way. std string port equals to 8787. Right, now there is also this particular string that is being allocated the IP address, IP addr, the IP address. Now IP address is being assigned this particular value. Okay, I guess now what might this particular thing be? Let me just copy it first. What might this particular thing be? It might just be an allocator. We don't know that. But let's just see what exactly this is. Find previous. Yep, it's an allocator. Let's just rename the allocators. What is an allocator? We can Google, you can obviously Google that. It will be it's a pretty simple thing. Let me just rename that to, let's say, these allocators are pretty interesting stuff. So let's rename that. Oops. Okay, right here, out here, if I just rename that, rename allocator, string allocator 0. If I just rename that, I can just go ahead and rename all these. This is the string allocator 0. Now out here, if I just go ahead and rename that to something like rename string allocator 1. All right, so out here we've got another allocator. All right, let's see. You can see we're trying to slowly figure out this entire thing. Now, what is this allocator variable? It's a class that's used to allocate stuff, allocate memory. Now by default, now this is the default allocator that C++ is using automatically behind the scenes. Even in this kind of code, that thing will be used automatically. All right. The next thing out here we are interested in is, let's say, this particular, we are setting the interesting IP to null. All right. Also, the IP address is being set to that particular value. Let's do that. IP addr will be set to, let's say, this IP address value. Let's say some IP address 13 or something. It was there. What was that? Okay, this value. Okay, let me just copy that. All right, out here, paste it. All right, so we are trying to slowly figure out stuff, and we have gone till this far. Now after that, we just go and see it's trying to do that in this loop part. Let's just copy this loop as it is. You can see we can copy that as it is out here. Now in the loop part, okay, in the loop part, what it's doing, let's just copy this line and try to figure stuff out here. Copy and paste it out here. Okay, what exactly is this doing? Let me just open it in full screen. Okay, now what exactly is this doing? This is pretty interesting. You can understand it to be something like, we'll be calling this operator plus. Now this is just a namespace. You can just ignore that. This is just namespace. You can just ignore that. We are just calling operator plus equals to of the interesting string function in this particular, and passing it the interesting string variable as well as particular thing that we are trying to figure out, right? So this can be translated to something like this is equals to, or this plus equals to this particular thing. All right, let's just copy paste that again. Now let's figure this particular thing out first, right? Now what exactly this local D8 is, let's just find that. Copy, and if I just go to Ghidra again, out here, oops, not this, Ghidra out here, let's just try and find that local F4 previous. I want to find the first occurrence of this. Okay, it's an undefined 8. Okay, so this is a variable. We don't really know what exactly this is. Okay, D8, we don't really know what exactly this is. All right, this is a problem. This is a big problem. Now, still trying to figure it out. Might be interesting. Now, this is a variable. Okay, out here again in Ghidra. If I just see the utilization of it or the initialization of it, well, something. Let's just rename it to, let's say, some interesting data, okay, some interesting data, and it's being initialized to some kind of data. All right, so some kind of data, let's say it's there. Now if I just move on, and let's see out here, we're trying to do something like we're trying to like, let's say, get the pointer to that particular some interesting data thing, get the pointer to that, and then try to cast that to a long. All right, and then add a long, or like add I times 2 to that, then translate it to a character pointer, and then dereference that. What exactly is happening out here? Well, this long out here is not really suitable, right? What exactly should be out here? Well, it's actually a pointer. Long is basically a 64-bit integer on a 64-bit system, which is basically a pointer. 64-bit integer is also a pointer. So long is a pointer. What we are doing is we are trying to cast this particular something data's pointer into a long, and add we are casting that to a pointer, so we can add this, that is I times 2. Let's say we are trying adding the twice I to the pointer of something, some interesting data, and then translating that, reinterpreting that as a character pointer and dereferencing that. Now what exactly is happening? Let me just tell you first what exactly is happening out here is, let's say we can assume any variable, since we don't know what type exactly this is, and it's some bytes. We can assume this to be something like character locally 8, or let's rename it to some interesting data to, let's say something. There is something out here. Let's say something out here. Now we don't really know what exactly is out here, but there is something. Now what we are doing out here is interesting string plus equals to, we are trying to add 2 times I. What is this? Is to the pointer of d8 we are trying to add twice I, and we are trying to see it as a character pointer and dereference it. So if you just try and figure it out what exactly this is doing, we can see that this is pretty much equivalent to this I times 2. This is pretty much equivalent to this. This is trying to copy, create the string from that data. Now what this data holds might be interesting, and we can't really see that because we are trying, if you see, we are just taking the data from every second index, not every single index. So we might have a, let's say, null termination in the between. So every alternative character might be a null termination, and we might get something noise in the decompilation, but actually it's having some interesting string in there. So this is what we have figured out till now. If we move on, we can see we are creating a client of httplib, again that library we saw in the Wireshark demo. In there we are creating a client with the IP address, with some variables, the client variable, and well, it's something like, let's say, rename this to client again. Client, it's equivalent to, say, client equals to httplib something and IP address that, and this is basically 8787, the port number, and we are trying to do a get. What is this variable again? This is something interesting again, I guess. What is this? Let's find that. Find previous references wherever it was declared. It's a client. Okay, it's a client. All right, it's trying to get that. Let's see. All right, it's trying to get that, and then we are trying to get the result of that by casting it to Boolean. Well, I guess it's checking whether the request was a success or not. Now if that was not a success, let's rename that to a success. If the request was a failure, not success, then we'll be doing this is basically printing out the error code see out. Again, the error code thing. Suppose there was no internet connection out there, and if it failed to get connect to that IP address, well, it will print out the error code. Again, we are trying to do the get the error message, and then we are trying to print that up. Otherwise, this is what is interesting. What we are doing is we are calling the elva2 will be the result of that, and then we'll be setting that particular string, let's say we name that downloaded data. Now this particular string is basically the password we downloaded. Now we saw the dummy password we downloaded from the IP address in the Wireshark thing. Now this is basically that particular thing. We're downloading that, we're casting it to a basic string, and then let me just do it to decimal, and we're just setting that up, we're just assigning that the downloaded stuff. And then we're just this result is being popped off the stack, and then again, if success, we are doing something that is enter the password. Okay, what exactly is out here is we are taking in we are printing out enter password and taking in the input. Let's say rename that to input, input. again we are taking the input and again checking whether the input is equal to the downloaded data, that the equal input and the password are the same or not. And in here, after checking that, we are doing that if this result, equality result, rename that again, equality result is equal to 0. Again, this is not null termination character. This should be a 0. Since it was a single byte 0, Ghidra thought it was a character, but again it was actually a 0, decimal in decimal sense. Now, if we just see that out here, we are printing up incorrect password. So if it was equals, if it was not equal, so it will be printing out incorrect password, and if it was equal, what will be printing out is the flag that we are supposed to get. That is the result we got out here. I guess let's just see, where was that? All right, the result out here, this incorrect password is being printed, and this is the result that is being printed, the flag. Now, how exactly is the flag being printed or calculated? Let's see that. Okay, what we are doing is calling hash of the local 48. What is the local 48? That is, I guess, let's see that. What is that? Find previous. Okay, all right, just a minute. Yeah, we are trying to assign a string, I guess. We are just trying to, yeah, we are trying to create a string, previous basic string 11. I guess this is again a variable, new variable for that particular, holding that particular string. Now, if I just see there, we are trying to call hash of that. Okay, after calling hash of that, we are again like assigning that to a particular variable. All right, we're assigning that to a particular string and then printing it out, I guess. All right, we're then printing it out here. I guess there was operator this. Yeah. Okay, I move back. All right, let's just find main. Okay, search all. Oops, sorry, Control Shift D. Okay, now back to main. We can see we were out here. It's printing it out here. This line is basically printing it out. This is the deallocation for the string. Okay, this is the final flag. Let's just rename this to the final flag. This local 48 basically is the final flag, I guess, out here. And then we're basically printing it out here. We're printing it out, the output. Okay, operator dot, and then this is the end line. Okay, this might be the end line character, and we are printing it out again, printing out the character, printing out the flag, and that's the output out here that we got from this particular executables run. This was the flag that was being printed. Now this is, I guess, a 64-bit integer, because hash is usually, let's just see the hash function. Yeah, it's a long. Yeah, it's a long. That's what I was missing. I thought it was a string. Now its hash is a hash return, so long. So if we go ahead and see that, well, this is basically a long variable UR3. What we are doing out here is, I guess, we are trying to cast it to a string and then print it up in this particular area, because, well, this is basically this line is basically, let's say the flag is equals to hash of our password, and then we are just doing it std cout flag, and then std endl end line, std end line. This line is basically being converted to all of this complicated stuff out here. That is, if we see that this is hash is being calculated out here first, this is the final flag, ag flag I, the flag I, the flag in the integer format, and this basically is first casting it to a string, I guess, and then we are all right. Okay, no, it's not casting it to a string. It's basically calling operator that with the flag. Now this, I guess, is the std cout operator. Again, all right, yeah, this is the std cout operator. This is the return from the cout from this particular area. So this is rename that to cout clone 0. All right, this is cout clone 0. Again, this is cout clone 1. Again, cout clone 1. Again, we are calling the push operator with that, and we are doing sending the end line. So it's basically printing that. It's not typecasting, it's basically printing that. Now if you just figure out how hash works, we don't even need to figure out how hash works. We can just go here, we can just copy this, because, you know, hash looks a pretty neat function, and I hope this will just work if we just copy and paste that in a compiler. It will compile itself, I guess, and we can just see, we can just compile it and use it in our code, right? I'm not going to do it right now. Okay, now back to main. You can go back by pressing this particular key out here. You can go to previous location, or the shortcut was, let's see, is that alt left. right? Again, we are just deallocating all the stuff we have allocated, and we are returning some return code. But basically, this was the reverse analysis or reverse engineered analysis of this particular executable. Now you can go ahead and do that for any challenge you're getting, and you'll be getting what exactly that particular thing does, and what exactly it is we have to do in order to capture the flag. Now, one more thing is, in some cases you might see that, well, this particular, you might not find main, even however hard you try, you will not find main. And also in some cases you'll see there is so much going on that we are not able to understand anything in there. Well, in such examples, I guess it would be a better idea to look for some other way rather than trying to reverse engineer using something like Ghidra, because, well, there are cases in which using this might not be feasible. For such cases, you have to carefully and analyze the strings of the executable and try to understand what it might be doing, and try to get an idea of what you might have to do for reverse engineering that. Also, you can take help of Google and a lot of any resource available online for help with these things. All right, so that's it for reverse engineering this particular challenge, and thanks for watching.